So we're going to start off with the platform overview, a quick review of the REST APIs and map components. Erik Lindeman is going to be leading that. And then move on to fleet and logistics with the new APIs and live demo of Bing Maps Multi-Itinerary Optimization. That's from Ashley Song. And then we will go on to a licensing summary from myself, Mark Finch. And then finally, we'll move on to a Q&A session at the end. Please feel free to add any questions as we go through within the chat window. These will be picked up at the end in the Q&A session. So, okay, now I shall hand over to Erik.
Great, thanks, Mark. So I'll dive in with why Bing Maps. So Bing Maps is a Microsoft cloud service trusted by enterprise customers worldwide. The Bing Maps platform offers all-inclusive pricing, 24/7 enterprise-grade support at no charge, and flexible licensing. And Mark will tackle the licensing towards the end. We'll move on to Maps and geospatial at Microsoft. So Microsoft has a rich history in mapping and geospatial with over 20 years of having a mapping web service. It was really one of the first enterprise cloud services at Microsoft for mapping. It's originally Microsoft had CD products, which were MapPoint. There was also a Terra server, which was a satellite service to access imagery. And then around 2000, Microsoft launched the MapPoint web service, which ultimately was superseded by the Bing Maps platform. There are thousands of enterprise customers using Bing Maps platform today for both public-facing applications to internal-facing solutions. Bing Maps is one of the most widely used enterprise geospatial mapping services in the world, used for everything from retail locators, dealer locators, real estate search sites, CRM, BI, asset management, emergency response, IoT, etc. And the Bing Maps platform is a very customer-focused service. We take feedback from customers and improve the product over time. We have global coverage. We really take pride in the developer support quality we provide to our customers. And Bing Maps is used in many native Microsoft products that you probably use day to day. So there are many Microsoft products that have dependencies on Bing Maps, and we'll talk about the third-party customer features, but I just also want to highlight that there are many Microsoft products, which we call first-party, that use Bing Maps as well, and I'll highlight a few here. So Excel is one of the Microsoft products that uses Bing Maps. So the challenge the Excel team had was they wanted to allow users to easily visualize spreadsheet data on a map natively within the Excel interface to support enhanced ways to do data analysis and make informed business decisions and just see what their data looks like on a map within the spreadsheet so they can explore the data. The solution was for the Excel team to use Bing Maps tiles, as well as so the tiles support 2D and 3D for rendering the data. They also use geocoding services to convert their location data to lat long so they can plot it on the map. And then they also use the Bing Maps geodata service to display the administrative boundaries on a map, so such as postal code boundaries. And the benefit Excel gets from this is they enable users to have compelling ways to visualize their location data within the spreadsheet and keep users within the Office ecosystem. Another example is Dynamics 365 for field service. So the challenge the Dynamics team had was they needed a service to do travel time and distance calculations, geocoding and mapping for field service product, which helps businesses enhance their service dispatching experience. So within field service, you can dispatch and find technicians that are closest proximity-wise, travel time-wise to a problem area that needs to be serviced. So the solution was for the field service team to use Bing Maps use the Bing Maps distance matrix behind the scenes to do the travel time calculations in bulk. They use geocoding to convert customer address information to lat long. And then, of course, they display that on a map. And the benefit is they increase customer satisfaction by dispatching the closest appropriately skilled resource to the service location. And finally, LinkedIn. I'm sure everybody has a LinkedIn profile. So this is a cool feature that I encourage everybody to try out. The challenge LinkedIn had is they wanted to provide a feature to users that showed what the commute time would be to a prospective job. So users could factor that data point into their decision on whether they should apply for that job. So the solution is for LinkedIn to use Bing Maps for routing with traffic, so users can see what the commute time would be from their home or place of where they're going to start their commute to the job location to see if if that type of commute time makes sense for them in different transportation modes, so car, public transit, walking. So these are all transportation modes that our routing service supports. And ultimately, it keeps their users engaged and returning back to LinkedIn for compelling features, and retains their subscription and revenue growth. So switching gears here, so we've been busy here at the Bing Maps team releasing multiple APIs. In fact, we've released 12 new APIs in the last 2 years. So that's an API release every 2 months on average. Many of these APIs were POI search, local search related. Many of them were logistics and fleet management related, which we'll get to in more detail. And then most recently, we released a few controls for iOS, Android, and Unity, which we'll touch upon as well. We also released an open source fleet tracking solution on GitHub. So in a nutshell, the Bing Maps platform is comprised of several different services. So we have our REST services, we have our web control, we have Windows geared APIs. It's definitely enterprise focused, supports multiple devices, so hence the iOS and Android and Unity support that we have. And jumping into one of the most important components of the Bing Maps platform is our roadmaps, or base maps we call it. We have coverage for every country in the world. We use a multiple data provider approach. So we use the best data provider for a given market or country. For example, we use Zenrin in Japan, NavInfo for China. We want our users to have the best map experience, so we go with the best provider for their market. We adhere to the geopolitical country border guidelines and sensitivity. So we're aware that, one map means something to another person. The boundaries and geopolitical ramifications of showing inaccurate map can be critical for our customers. We also support localization support for over 75 languages and countries. So that's the map labels you see on the map. And we're continuing to always enhance the base map. For example, we've expanded the building footprints that we show on the map by default. Prior to recently, we only showed building footprints in urban corridors. Well, we've expanded that a few weeks ago to at least in the B2B control, and that was already in the consumer site. But we now have footprint data for rural areas as well as suburb areas. It just gives better context for our users and for your users. When you display your data on the map, you want to see the building footprints. We also released last year a map style editor. So this is the ability to control the look and feel of the map. So you can specify RGB colors, etc., in your code, but we created an easy to use interface. It's a Windows 10 app where you can go in and control, the color of the water and different attributes of the map. So it'll match your branding and your business requirements. We understand that it's oftentimes very important to customize the map for the look and feel that you desire for your users. Another aspect of Bing Maps that is highly valued by our customers is our imagery. So this is, the aerial, satellite, bird's eye, and street side. So satellite aerial, this is ortho imagery, top down. This is, table stakes for any mapping service these days. We use a mix of satellite and aerial. Aerial is usually higher resolution. Aerial is typically 30 centimeters. Our satellite imagery is usually 50 centimeter resolution. We offer satellite imagery for the entire world. We're committed to refreshing this imagery type as often as we can with the highest resolution possible. Bird's eye imagery is also a pretty unique feature to the Bing Maps service. It's the 45-degree angle. You get all four cardinal views. We have bird's eye for US, Canada, and Europe. Bing Maps was one of the first web mapping services out there to have this imagery type. Really valuable in real estate and other scenarios where you really need to see all the different angles of a building, in different contexts. And we've been busy refreshing this imagery over the last 12 months. We've released, refreshed, and expanded imagery for bird's eye, reaching over 100,000 square kilometers and over 100 cities in the US. And we intend to expand that in Europe as well. And bird's eye imagery typically is sub 10 centimeter resolution, so very, very high resolution imagery. So moving on to our REST services. So this is the REST services and the REST APIs are where you'll find the geocoding, the point of interest in local data searching, routing, access to static maps and map tiles. Oftentimes we have customers that want to access the map tiles directly. They don't necessarily want to have to use the web control to consume the tiles. So we offer that flexibility within the REST service. And sometimes customers just want a static map they can embed in their site or into documents. So this is where that feature is found as well. And then we also have time zone data, auto suggest, elevation data, traffic incidents, boundary data such as neighborhood polygon information. The Bing Maps Spatial Data Services is also a widely used service by our customers. So this is really where you'll find batch geocoding. So if you have a large set of addresses that you want to just upload a file and have them batch geocode and then download the file and import onto your side, the Spatial Data Services is where you'll find our batch geocoding feature that supports forward and reverse geocoding. We also offer data hosting as part of the spatial data services. So you can upload your custom points of interest, KML, shapefiles for polygons, and store that within your Bing Maps account to then query against. So many of our locator customers will offload the burden of having to host and do proximity searching against the data on their side and simply upload it to their Bing Maps account to query against. And that supports find nearby, find along route, and find within map bounding box. And then this is the spatial data services also where you'll find the geodata API that I alluded to earlier. So this is administrative boundary data. So if you want to get the polygons for countries, counties, provinces, neighborhoods, this is the service where you'll find that data. So jumping into our map controls, the web control, which is our JavaScript control, is by far one of our most widely used services to access the maps. And this is where you'll find the base map, the aerial satellite imagery, ortho, bird's eye, and street side imagery. The web control also has multiple modules so that you don't have to make separate calls to the REST services to get stuff like auto suggest or geocoding. You want driving directions and all the supported modes like driving, walking, public transit. There's a module just to get that directly within the web control. Traffic flow data if you want to show current traffic conditions. And then there's a host of spatial math libraries, drawing tools, heat maps, stuff you would expect with any JavaScript-based web control. And this is where you'll be able to customize the map as well in terms of localization. So in this example, there's a map that's in Spanish for Spain. This is the Madrid airport. And then even the auto suggests you can localize the results. So if it's a Spanish speaker, they'll be familiar with the results that come up. We also have a control for UWP, or Universal Windows Platform. This is for bringing maps into native Windows 10 apps. You can control the map styling, everything that you get from the web control. In addition, the 3D mapping that is in the Windows 10 map app is also part of this SDK. So you can, in theory, create a application that takes advantage of the 3D maps that are in the Windows 10. And if you haven't tried the Windows 10 maps, just simply type in maps into your Windows 10 PC, and you'll see the map app pop up, and then you can navigate in 3D within that map app. So that's essentially taking that same content and consuming it through your own custom map. And it also supports the offline mapping, geocoding, and routing that comes with the Windows 10 map app as well. So if you wanted to create an app that is able to access the offline mapping that you've stored within the map app, you can access that as well through the UWP SDK. So we recently released previews for iOS, Android, and Unity. We're hoping the iOS and Android controls will come out of preview within the next 2 weeks. Look to the Bing Maps blog to see when that goes out to general availability, and then you can use that for your production applications. So we created an iOS and Android controls so that customers can have a uniform feel and experience across all of their applications. So they can use Bing Maps for their web applications, and then Bing Maps, of course, for their iOS and Android apps as well. We also released a Unity SDK for Bing Maps. So this is where you can bring the Bing Maps content into Unity solutions. So this too has the 3D maps that are similar to what's in the Windows 10 map app. This should be coming out of preview hopefully in the next few months. We recently released a blog post that is a how-to guide on creating Unity map applications using the Bing Maps SDK. So I encourage you to take a look at that and play around with the that control. And also I wanted to mention the fleet tracker solution that we released on GitHub. So this is really a Kickstarter solution geared for small and medium-sized companies that don't have the time or resources to create a asset tracking solution. So basically, just take this code, you deploy it to your Azure account or subscription. It has a nice interface where you can track your assets. It's iOS and Android based, so the assets that are being tracked would have to be iOS or Android based. So you install the iOS or Android apps to those devices, and then you register them with your solution, and then they're trackable. The asset has the ability to turn off and on tracking, but since this is an open source solution, you have full customization on how and when you would want to use these features. So you can just take certain features that you want and use those, or you can use the full solution as well. So very easy to install, nice admin UI to manage your assets. There's geofencing, there's reporting, breadcrumbing to look at historical routes, and then there's APIs as well, so you can access the data you want from that installation as well. So I encourage you to take a look at that on GitHub. And on that note, this is a good segue to hand it over to Ashley to talk more about our logistics and fleet APIs.
Thank you, Erik. So I will take control from here. So you already talked about the fleet management. So my name is Ashley Song, and I'm a program manager at Microsoft Maps and Geospatial Group. So I will walk you through some of our Bing Maps API for transportation and logistics. So as you may already know, Bing Maps offers a variety of targeted APIs to help businesses solve transportation and logistic challenges. So these APIs can help the customers do optimization or do drive analysis across routes and resources to help them save money and time. First comes the trucks routing API. Note that not all trucks can travel the same routes as other vehicles can because of the road restrictions and vehicle constraints for the trucks and some commercial vehicles. The truck routing API calculates the safe and efficient routes that can take into consideration these special requirements. For example, a truck is transporting some flammable materials between two locations in Pittsburgh, as shown on the map, as illustrated on the map using S for start and E for end on the map. So based on the output of the API, we can create the visualization of the routes on the map for comparison purposes. For example, the truck route is highlighted in green, and the routes that vehicles not carrying the flammable material is highlighted in red. As shown in the visualization, the red route goes through the Liberty Tunnel, which prohibits any flammable or explosive materials. As a result, the truck carrying the flammable material needs to take a longer route, which is the green route, about 6.2 kilometers, comparing to the red route for regular vehicles, which is about 4.9 kilometers. On the right, you see a few pictures. These show the some other road constraints that it may impact the truck routing in addition to the flammable cargo. For example, the bridge have height limits for trucks to go beneath. Longer trucks have some difficulty making some turns, and certain trucks need to avoid roads with steep gradients. Let me advance it. So currently, the truck routing API supports about 80 countries or regions. The API calculates the routes with respect to some of the truck-related restrictions, such as size, weight, and the road, bridge, or other regulatory restrictions as summarized on this slide. Moreover, we also recently added support for border crossing restrictions to the API because some of these loads are restricted between countries or areas. For example, a truck needs to deliver some loads from Asheville, Tennessee to Jacksonville, Florida, and the requirement is to avoid the state of Georgia during the routing. So on the right, you can see the example of the JSON block defines the start and end location. The road path parameter specify the API output should take a set of the point values, like the latitude and longitude that describe the route's path in the response. The border restriction parameter defines that the state of Georgia should be avoided in the route. So you can see that in restriction, we define US-GA, that's using the ISO code for regions and countries. Below the example, you see the visualization of the route path on a map. So the black dashed line shows the regular routes without carrying any flammable goods. And that routes go through Georgia. While the blue solid line shows the routes avoiding the Georgia as the API request has specified. So for the truck routing API, the limit is up to 25 waypoints in the request. Next, we can look at the distance metrics API. So this API calculates the travel time and travel distance between a list of origins and destinations. It supports 3 different travel modes: driving, walking, and public transit. The output of the API is pairwise travel distance and travel time between the origins and destinations. For example, if you have 2 origins and 3 destinations, the output will have 6 pairs. For the driving mode, it's optional to specify the start time, end time, and the resolution, which is how the Oh, sorry, I forgot to mention. So for the driving mode, you can actually, you have the option to use the historic travel data to do prediction on the traffic. So for this one, you can specify the start time, end time, and resolution. And the resolution is used to define the histogram interval. The default is 15 minutes. You can do 15 minutes, 30 minutes, 45, or 1 hour. So for example, if you look at the black picture at the lower right of the map, that blue histogram visualizes the travel time, and the green histogram visualizes the travel distance for every 15 minutes interval within 24 hours time window from the start time for that route for some of the origin and destination pair that you request. You can see that the travel distance and travel time actually varies throughout the day for the same pair of origin and destination. And this API itself is often used to as a baseline to solve the traveling salesman problem, which is to find the shortest possible routes that visits all the locations and return back to the origin. And it's also used to solve the vehicle routing problem, which tries to find the optimal set of routes for a fleet of vehicles to deliver to a set of customers. This API limit is either 2,500 origin and destination pairs, or if you use the traffic histogram prediction, it's 100 destination pairs if you use async request. The next API we will look at is the Isochrone API. Isochrone API calculates the isochrone polygon that can be traveled within a given time or distance, as defined in waypoints, max time, or max distance. The date time parameter is optional. It's used to use the predictive traffic data when calculating the time-based isochrone routes for driving and transit at specific time. You can also specify the API request to optimize for distance, for time, or for time with traffic. The API supports 3 different travel modes. A good use case is for working couples who look for home where the 2 work isochrone can overlap. For example, the husband drives to work and wife takes buses, and they want to find a home within 15 minutes travel time from their work locations. Just as an example. And I think Erik also mentioned that LinkedIn used some of this functionality in their offering. Other common use cases of Isochrone API include delivery, logistics, geofencing, or stolen vehicle recovery. For example, if we have a company that needs to determine the delivery locations that can be reached by electric vehicles without having to return back to the shop for recharging. So assume that the battery, vehicle battery can last for 100 miles or 160 kilometers. We can set the distance, the max distance to be 50 miles or 80 kilometers, which means the round trip is 100 miles or 160 kilometers. So for this API, a synchronous GET request is recommended for shorter travel time, less than 13 minutes, and distance less than 24 kilometers. And you can use asynchronized requests for larger isochrones. So with the massive number of GPS-enabled devices used today, billions of GPS points are being collected by mapping services. And the GPS data can be a treasure, which can lead to new knowledge or discoveries in location-based services. However, the real GPS traces rarely match real routes, which makes the post-analysis of such GPS traces or points a challenge. Our Snap-to-Road API takes a list of lat-longs and returns a list of objects containing lat-long, street names, and speed limit that form a route mapped to the road on a map. So users can request the points to be interpolated, resulting in a path that smoothly follows the geometry of the road. This API supports synchronized requests up to 100 points and asynchronized requests up to 1,000 points. Some example use case of the Snap to Road API include the pay-per-mile model for rental or insurance, or asset tracking or driver analysis to track drivers' routes, whether the driver is adhering to the posted speed limits, or monitor if the driver goes off the route. So last but not the least, the most recent premium API we launched is the Multi-Itinerary Optimization API, which we announced at Microsoft Build in May 2019. So for businesses focusing on service dispatching, sales field management, or customer pickup and deliveries, how do you get someone or something to multiple places in an efficient way? So this MEO API aims to address the route planning and optimization challenges of assigning a fleet to deliver services to multiple locations. For example, you can have trucks sending goods to distribution centers or from distribution centers to retail stores, or shuttle vehicle picking up passengers and dropping them off at different locations, postal services delivering mail or packages, waste collection from commercial or residential locations, or professional visiting different work sites for different sorts of services. So traditionally, these route planning and service dispatch have been done manually, which is time-consuming and difficult to find the optimal solution, especially as the number of locations to visit increases. Our Bing Maps Multi-Itinerary Optimization API automates the route optimization process and helps schedule the dispatch to reduce travel time, wasting fuels or human resources. Consider a shuttle dispatching scenario on Microsoft campus. A shuttle starts from transit center, stops at 4 buildings to pick up or drop off passengers, and ends the route at building 33. Traditional route is done in a first come, first serve manner. Without any route optimization, the total travel distance will be 8.5 kilometers and take about 32 minutes to go to the final stop. Using the MEO API, the sequence of the stops is reordered to optimize for the travel distance or time. The optimized routes save about 34% of the distance traveled and 26% of the driving time. And this is just an example of a single agent or itinerary, and the API can do much more. So if there are many locations to visit, we may need multiple drivers to service all the locations, and we need to divide the itineraries among all the drivers. So this is what MEO targets. It builds the multiple itinerary while optimizing the routes among all the drivers to save the total travel distance and the travel time among the drivers. So the MEO API can take both the locations available time windows and agents availability into account. As shown in this example, this is an example use case of 2 agents. So 2 food inspectors, Charlie and Angie, as defined in the first table. They need to visit 13 restaurants for the food inspection, as defined in the second table. So the first table has the shift information for the 2 agents, including the shift start time, shift start location, and shift end time and shift end location. And the second table summarize the available hours for each restaurant, the dwell time that the food inspector need to spend at each restaurant, and the different priorities if they may have. Note that some restaurants only open in the morning, while some restaurants only open in the afternoon. And yeah, let me go next slide. So here is the example post request body in JSON format. We need to define the information about the agent and their shift. In the post body, we define 2 shifts for Charlie, 1 shift for Angie, and the start and end location for each shift. In the post, sorry, I think it's jumping. Yeah, so in the post body, we also need to define the operating hours, the dwell time, and priority of each item. Once you have the post body ready, you can post a synchronized request with the agent shift and itinerary item defined as in the post body. You can use the HTTP post request URL, replace your own Bing Maps API key. Actually, for requests with fewer agents or item waypoints, you can also use HTTP GET request. We recommend using URLs keep the URL under 2083 character length. Here's a snippet of the JSON response returning information about async request. The response lists the routing instruction for each agent, including leaving from the start location, traveling between the locations, and visiting each location. The response also gives a summary of the routes for each agent, such as the lifelong of start and end locations, and all the waypoints, the total travel time and the total travel distance. When the request is successful, HTTPs. Here is just a visualization of the meal generated route based on the input data we had. Note that one of the restaurants is only open between 7 a.m. and actually 7 a.m. and 1 p.m. and agent Angie only works in the afternoon, starting at 1 p.m. So the API will consider these constraints and assign Charlie to arrive at that Montreal Espresso coffee shop before 11 a.m. during his first shift, and he has enough time to finish his visit before the restaurant closes. And in the afternoon, Charlie has 4 other locations to schedule. As scheduled in his second shift before he can arrive at home at 5 p.m. For agent Angie, all the 5 places assigned are available to be serviced in the afternoon, including the high priority location we defined, the Tiger Rail, and his start and end location for the shift is at the same place. So in short, the itineraries are for both agents and back their location schedule preference while observing the restaurant's open hours. Yeah, so that's all I would for and logistic APIs today. For more information about these APIs, please visit our API documentation page. With that, I would like to handle the presentation to Mark, who will talk about the licensing options.
Thank you, Ashley. Yeah, we'll go through some licensing options now for you. So the first is a link to microsoft.com/maps/licensing. You'll find some further information there. But the next protocol would really be to speak to Grey Matter, and we'll give you some information on the next slides too. So we've got three types of license models. There's transactional, user-based, or per asset with mobile asset management. So with the transactional, we don't really mind how many users you have. You are just consuming transactions. With the user-based, this sometimes suits users who, or customers who want to have a fixed cost per user. Normally works better with low numbers of users. If you've got a high number of users, then we would recommend transactional. Or if you've got a fleet management application, then you would need the mobile asset management. The premium features that have been spoken about in the webinar, they're all available with transactions. They're not available with the user-based licensing, and most of them are available as an add-on to the mobile asset management licenses. And just a little piece about the Bing Maps ISV licensing program. So this is a program that allows ISVs or systems integrators to who are building applications for their customers to include Bing Maps within the applications, whether they be packaged apps or software as a service. The idea is that you don't have to get your customers then to license it on there for themselves. It also gives you the ability to divide the licenses that you have purchased across your user base. And you can easily scale the application because you take out an initial upfront bundle, and then you can report any additional licenses quarterly in arrears. And just some of the resources that we have alluded to throughout the presentation, starting with the how to get started, there's a couple of links there. How to create an API key as well, just to go to microsoft.com/maps/create-a Bing Maps key, followed by some code samples, and we have an interactive SDK, and also some more code samples on GitHub. If you want some further licensing information for ISVs, please visit the Grey Matter showcase page. We have a link here, and there's also a self-help information for support on microsoft.com/maps, and just choose the support link from there. And for any news and updates, just go to the Bing Maps blogs.bing.com/maps. So finally, we'll move on to Q&A. I see that there's plenty of activity in the chat window, which Justine has been answering. I'm not sure whether there's anything that hasn't been answered there. Perhaps we can go onto that in a second. But also, we will open your mics now for anybody who wants to ask any questions.
Any questions out there? Ashley, Mark, or this is Erik, are happy to answer any questions. Maybe I'll take one from the chat window. There was a question on whether there was a cost for the Bing Maps fleet tracking solution. No, the solution itself is free. That's out on GitHub. You do need to make sure that you have proper Bing Maps licensing for the number of assets that you will track in that solution. So let's say you have 100 assets you want to track through that solution. You would need to make sure that you are licensed for the 100 assets within Bing Maps.
Erik, there were a couple of good questions for Ashley as well. Hi, everybody. This is Justine. Ashley, there were questions about additional costs for the multi-itinerary API and whether you can support 2 sets of availability hours.
Yeah, that's a good question. So I can support the yeah, depending on licensing type. And if you can support shifts. So in the example, Charlie actually has 2 shifts, and Andrew has 1 shift. That's a total of 3 shifts. That's it.
Yeah, and just this is Erik to speak to the multi-itinerary optimization API licensing. So essentially, it's the number of agents times the number of locations. So if you have 10 agents, 100 stops, you just multiply that, and then that's the number of transactions generated for that specific API call. So you need to just make sure you have enough transactions per purchase to cover however many agent and stop locations that you need to calculate over a year's time. I think there was a question also on whether addresses are supported instead of coordinates for the multi-itinerary optimization API. And this is true for the distance matrix as well. Currently, it's limited to coordinates, so you do need to geocode your data before you run it through those APIs. Perhaps in the future, we may support addresses, but at this time, you do need to pass
Actually,
the
I
miles.
think I think we currently actually support the address for distance metrics.
There was a question around whether we're going to make the presentation, the slide deck available. Yes, we will make that available to the attendees.
There was a question also around saving addresses obtained through the reverse geocoding API. So you may store geocodes whilst you hold a Bing Maps license.
I see a question about not plotting 90,000 records on a map using SVG pushpins. The V8 control team's been doing some extra work on that. If you'd like to reach out to our support team, they'll help you with the optimization of those 90,000 records. And just to put a plug in here, that support team is available to any Big Maps customer, and they will definitely help you with any of your issues. And you can find them by going to microsoft.com/maps and support.
Just to add to that, Justin, they can also reach out to Grey Matter for any of those questions as well.
Absolutely. As you can tell, we have a very tight relationship.
It looks like there's a question on satellite imagery for Eastern Germany, and if it's possible to access an archive of historical vintage of the imagery. We only make the current vintage available, so we don't keep older versions of the imagery or make that available. There's a question on whether you can load Bing Maps without HTML. Yeah, so that's where our other mapping services, like our static maps, are a great fit for a scenario where you just want to embed a map. It won't be a map that you can pan and zoom in on, but that's one approach to getting the map and not needing to use the web control. And then there's other options as well, like the WPF control if you have a Windows client solution, or the UWP, if you have a Windows 10 application. There's a question on custom points of interest data added to Bing Maps available offline in client apps. So if you have your own set of custom points of interest, you can absolutely store that on your site in a database, and you could query against that. And then you can also upload those custom points of interest into the Bing Maps Spatial Data Service that I mentioned earlier. You do need to make a request to the Spatial Data Services query API to retrieve those custom points of interest. But if you're hosting that custom points of interest on your side, then you can absolutely get that data offline. But and if you want to load it on a map, then you would obviously need to have online access there.
And I just saw that question to revisit. Can the set of available hours be given for the routing API? So currently, for each location, we only support one start time and one end time. So the answer to that is no. But as I mentioned earlier, for the shifts, we support multiple shifts per agent. We are looking into future improvements to the API, which include like looking at multiple working hour, like open hour windows per location. But currently, we only support one per location.
I see a question regarding Google getting different results than Bing. We do use different sources, so it is not. It's understandable that we might get different results. You'd have to look at the particular area and look at the particular time of day. I personally have an Android phone, so I find Google quite optimistic on my particular route, but it really does vastly differ depending on what part of the world you're in. So we'd be happy to work through your specific location and your specific area question.
Okay, I think we have managed to get through most of those. So guys, if you've got any more questions that you want answering, if you think of any more after the webinar, please email mapping@greymatter.com and we'll do our best to answer those for you. Also, if there are any that we haven't managed to get around to on the meeting chat that you want clarified, again, just please email us at mapping@greymatter.com and we'll get those answered for you. Finally, just a thank you to Erik and Ashley and all the team at Microsoft for making this webinar possible. And just a notification that all registrants will receive a link to the recording of the webinar too. Thank you very much for your time, everyone.